Hey guys, we're going to be working on the quiz that we're doing on parallel lines and proofs. And I'm just going to be working through all the problems. So fast forward, go watch whichever ones you need to see, but let's make sure you know how to do all of this in time for our quiz. The first one says, write an equation parallel to 3x plus 2y equals 10 that goes through point B. Well, because it has to be parallel to this line, then we know that it has the same slope. So what I would do is solve this for y. I'm going to get it in the format of y equals mx plus b so that I can know the slope. So the first thing I would do is subtract 3x, and I would have 2y equals negative 3x plus 10, and then divide everything by 2, and I would have negative 3 halves x plus 5. So I put it in y equals mx plus b. That means that m equals negative 3 halves. And that's the slope I'm going to work with. So write an equation parallel to that. So this is going to be my m. It has to go through point B. That means b is going to be my x and my y. So we know x equals 2, y equals 4, and m equals negative 3 halves. Those are the things we know we have to use. So y equals mx plus b. I'm going to plug in 4 for y. I'm going to plug in negative 3 halves for m, 2 for x, and solve for b. Well, the 2's would cancel out, so 4 would equal negative 3 plus b, so b must equal 7. So my equation for the entire line is y equals negative 3 halves x plus 7. Boom. Next one says write an equation perpendicular to AC. So I'm going to go look at AC real quick. That's 1 comma negative 7. That's A. And C is at negative 3, negative 10. So there's A and B. Sorry, A and C. 1 comma negative 7 and negative 3, negative 10. And I need it to be perpendicular to that. So I'm going to get the slope. So the slope of AC would be negative 7 to negative 10 would be minus 3. 1 to negative 3 would be minus 4, or positive 3/4. So we know the slope is positive 3/4. The perpendicular slope would be negative 4/3. So this is the slope I'm going to use, and this is going to be my x and my y. So we know x equals 6, and we know that y equals 5 because of the coordinate. So we do y equals mx plus b. We know we have to use the perpendicular slope, and we know what x and y have to equal. So plug in 5 for y, plug in negative 4/3 for x, for the slope for m, plug in 6 for x plus b. Reduce that. 6 divided by 3 is 2. 2 times 4 would be negative 8. So b equals 13. And that's a whole number again. I just made these up. I assumed that at least one of them would not be a whole number. They may not be a whole number, so don't think it's going to always work out so nice. But the final equation will be y equals negative 4/3 x plus 13. So we got the perpendicular slope to AC, and we went through point B. Or not point B, we went through this point. Identify the angle relationship and the transversals. Okay, I've gone over lots of strategies on problems like this, but we have angle 5 and 20. One way you can do it is trace the angle, put the dots, trace the angle, put the dots. This is the line that has 2 dots on it, so that's our transversal. Here's the other line for 20. Here's the other line for 5. I am not going to go through that whole process every time, but like you have to have some way that it works for you. But those are on the same side, one in, one out, which makes them corresponding angles. Identify the transversal. Well, what is the line they both use? They both use line D. So the transversal would be line D. And there's your answer for that one. Oh, no. I'm on the original, so the erasing is going to be hard. I'll have to do better next time. So let's see what we got here. Oh, I can do it. I can do it. There we go. The next one, 9 and 15. Another strategy I've showed you is to just trace the angle, right? Here's 9. Here's 15. Here's the line they have in common. And they're both on the inside. They're same side inside. That's going to be same side interior for 9 and 15. And which line do they have in common? It was line E. So there's that one. How about 2 and 19? Angle 2, angle 19. Do they have a common line? Right? Like if I do my dot method, is there a line with 2 dots on it? Nope. Here are the lines for 2. Now it touches, but that's not the same line, right? Here are the lines that make 19. And the answer is there's just no relation. They don't have any common lines. So 2 and 19 would be no relation, which means there's also no transversal. All right, I'm going to go a little faster through the rest of them, but it's the same idea on all of them. Here we have 14 and 15. I can do like the letter Z. I know those are going to be alternate interior angles. And what line do they have in common? It was line E. 11 and 12. Well, those are just side by side. That's just a linear pair. They're right next to each other, side by side, linear pair. And that would be no transversal as well because they're on the same intersection. And then 11 and 21. So here's angle 11, here's angle 21. They do share a line. They are on opposite sides. They're on the outside. Those are going to be alternate exterior angles. And they have line C in common. All right, moving along. Write a 2-column proof. Oh boy. Oh boy, are we scared right now? Given A is parallel to B, there's nothing to do with that other than mark it up. So I'm going to label that in my picture here, that A is parallel to B. Whoop, so it's these 2 lines that are parallel. And angle 20 and angle 16 are the same size. So angle 20 and angle 16 are the same size. Prove that 2 plus 16 equals 180. All right, we can do this. So we make our 2 columns. Here's my given information. They mentioned angle 2 here, so is there a way to connect 2 to 20 or connect 2 to 16 would be my question, because 2, 16, and 20 are the 3 angles that they mentioned. It helps to focus your attention on what they mentioned. And I know because of the blue parallel lines that 2 and 20 are going to add up to 180. So I know that the measure of angle 2 plus the measure of angle 20 equals 180. And that is because of the parallel lines. That's the same side exterior angle theorem. Then they told us that angle 20 and 16 are the same. So can I make that angle 2 plus angle 16? Can I take out 20 and replace it with 16? What do you call that when you remove and replace? It's called a substitution. And that's actually it. That's all we're trying to prove here. So we're already done. Sometimes they're real short. But yeah, that's the entire thing. Next one. This one's a much trickier one, I believe. It says write a 2-column proof. First, they tell us that DG is an angle bisector. Well, that means that these 2 angles have to be equal. Now, you can't just mark it. That's one of the big mistakes people make is they mark it, but they don't actually put it in the proof. So we need to make sure that's in here. We know that the measure of angle 18 equals the measure of angle 19. We know that. And that is just the definition of angle bisector. Okay. Then they tell us that 8 plus 11 equals 18 plus 20. Now, let's just make sure we understand which angles they're talking about. 18 and 20, and then 8 and 11. So we know that 8 plus 11 equals 18 plus 20. Okay. We're trying to prove that EF is parallel to DC. So let's look at those real quick. Here's EF up here. Here's DC down there. we have information up here and down here. There's only one connection between the purple lines. And actually, I'll make it a different color here just so we can kind of see it a little bit better. So we're trying to get these two lines to be parallel. And the angles we know something about are here and here. Well, the only line that can get us anywhere close is this transversal, but it goes all the way to 10. So this might be a little tricky to see, but what I'm going to do is set up two equations. Using angle 20, what do we know about all three of those? We know that 18, 19, and 20, when we add those up, they have to add up to 180. And that's just because they form a line. Form a line. Definition of a line, form a line, I don't know, whatever you want to put there. Form a line. And then what about up here? What do we have with these three angles? Because we need to involve 10. 10 was the only one that has that transversal that goes down to the other angles. So 10, 8, and 11, look at those. We know that the measure of angle 10 plus the measure of angle 8 plus the measure of angle 11, oopsies, have to be 180. That's called the triangle sum theorem. You can just write triangle or whatever, I don't care. It's because they make a triangle, right? The triangle sum theorem says that the three angles of a triangle have to add up to 180. Okay, so we know that's true. Now, what is something we've said all along? We've said if two things equal the same thing, then they must be equal to each other. So we know that the measure of angle 18, 19, I keep doing that, and 20 have to equal the measure of angle 10, 8, and 11. And that's another substitution, right? We took out 180 and replaced it. Okay. Well, we're kind of stuck, but remember what they said here. What is 8 plus 11 the same as? 18 plus 20. So look right here, 8 plus 11. What can I change 8 plus 11 to? I can change it to 18 plus 20. And that's exactly what I'm going to do. So the measure of angle 18 plus the measure of angle 19 plus the measure of angle 20 equals the measure of angle 10. And what we say this is equal to? 8 plus 11 equals 18 plus 20. And that is another substitution. And it would have been okay if you just did those on the same line. All right. Why did that help? Well, now we have an 18 on both sides. We can subtract them. We have a 20 on both sides. We can subtract them. Can we do those both at the same time? The answer is yes. So if I subtract 18 and 20 from both sides, I'm left with the measure of angle 19 equals the measure of angle 10. And that is by subtracting from both sides. Well, if 19 and 10 are equal, look at those. If 19 and 10 are equal, does that mean our lines are parallel? And the answer is yes. So we now know that EF is parallel to DC. And what kind of angles are those? They make the letter Z. So that's the alternate interior angle theorem's converse. Whew. There we go. That's a tricky one. All right, solve for X and Y. We've had this picture before. We know it's got to be A plus D equals 180. And we know it's B plus C that equals 180. The big mistake people make is they tell me these add up to 180. And I've told you guys this before. We've talked about this before. If you thought those added up to 180, I need you to listen and listen real good. We know that this line, AB, is parallel to this line. The arrows are on there. If you are working with this corner and this corner, if you trace those corners, you have traced the same purple line twice. You do not have properties unless you're using two different parallel lines. There's only one purple line in that picture, which means there are no parallel lines. If you go from here to here, you make the letter C. Yes, those are same side interior angles, but they don't have to add up to 180 unless the lines are parallel. Is the left side parallel to the right side? No, you can't go left to right. You must go top to bottom on this equation. It is A and D that add up to 180, and then over here, it is B and C that add up to 180. You must work between the parallel lines or it will not be correct. You've got to get that right. So we have two equations here. The first equation is A and D are going to add up to 180. That is 8x plus 3y plus 103 plus x minus 5y plus 8 is 180. I'm going to clean that up. You have 8x plus x, that's 9x. 3 and negative 5y is negative 2y. And then move 103 and 8 to the other side. We want it in the format of ax plus by equals c. That's the easiest format to work in for most people. So minus 111 would leave me with 69. So there's equation number 1. Equation number 2 is going to be based off the right side. That's going to be x minus 9y plus 66 plus x plus 6y plus 91 equals 180. We know that those two corners also add up to 180. We want it in the same format, so that's going to be 2x minus 9 plus 6 would be minus 3y. And then I want to make sure I get this right, so I'm going to type it in, but it's going to be 180 minus 66 minus 91, and that's going to equal 23. So there's my two equations. So 9x minus 2y equals 69. 2x minus 3y equals 23. And now we need to solve this with elimination. I think it's going to be easiest to make the y values the same number. So I'm going to multiply the top row times 3. And I'm going to multiply the bottom row times negative 2. And what's this going to do? It's going to give me a positive and negative 6 for the y coefficients. The top one's going to be negative 6y. The bottom one's going to be positive 6y. You're trying to make one of the coefficients the same number but opposites. 6 and negative 6 gets that done. But if I multiply one thing, I have to multiply all things. So at the top, we're doing 9 times 3, 2 times 3, 69 times 3. And you're going to get, when you do that, you're going to get 27x. You're going to get minus 6y. And make sure you get this right. 3, it's going to be 207. 3 times 69. Oh, gosh. 16. I keep messing up. 3 times 69 is 207. Yeah, just want to make sure I got it right. The bottom row, everything is going to be times negative 2. So negative 2 goes to all of those numbers. You can't just do some of them. You have to do all of them. That's going to be negative 4x, positive 6y, and negative 46. So when you do this, you're going to end up with 23x. The y's are going to cancel out, equals 161. And so x equals 7. Let me make sure. Divide by 23. Yes. So that's what we're looking for there. Perfect. Once you know x, you go plug it in, you solve for y. It doesn't matter where you plug it in. I'm going to plug it into this equation. So when I do that, I get 2 times 7 minus 3y equals 23. So that's 14 minus 3y equals 23. And so negative 3y equals 9. So y equals negative 3. And your answers are x equals 7 and y equals negative 3. And that's what we were trying to do. So we are done. All right. Find the measure of the indicated angles given all this. Let's start filling in what they gave us. CHK is 30 degrees. HJK is 80 degrees. MCK, angle MCK, is 120 degrees. KJ is an angle bisector. That's all of our given stuff. And so we got to work with it. Oh, and then they tell us parallel lines. That's one of our favorite things. So we've got parallel lines here. They told us that these are going to be parallel to these. Woo, those are some parallel lines. So what do we do with all this? Whew. Biggest thing you have to know this unit is what to do with parallel lines when you have them and how to know if you have parallel lines. Everything I marked in blue is stuff they gave us. You got to make sure you're filling out everything they give you first. And then you got to sit there and try to figure out all the missing pieces. You got to be looking for every little detail. I see a lot of stuff I can do, and I've told you guys, vertical angles, linear pairs, get those out there first. You never know when they're going to be helpful. So I fill out that intersection first. You can look for things that use parallel lines, but right now, I don't really know a lot with parallel lines. I do know one thing, but I'm going to ignore that for a second. I'm going to look at this triangle, though. 80 and 30 in this corner make a triangle. Well, 80 plus 30 is 110. That means this corner has to be 70, which means this has to be 70. And that busts some stuff wide open because now I have another triangle, right? Aren't these going to form a triangle over here? So 170, that leaves me 10 degrees for this corner. Okay. So now I'm looking, what can I do? Vertical angles, these are going to be 70 and 70. So what does that leave us with for the others? Well, 70 plus 70 is 140, so that would leave me with 40 degrees for the excess. So now I got all those angles, 70, 70, 40, 40. What can I do? This 10-degree angle touches a blue line. So when you get stuck, and you're going to get stuck on this quiz, when you get stuck, look for angles that use parallel lines that you probably haven't done your parallel lines yet. If you have an angle that touches a blue line, in my case blue, great. Trace the blue line and turn. Basically, I've traced that angle now. And we keep going until we hit blue again. That means this corner has to be 10 degrees as well. Well, if this is 100 and that's 10, we got another triangle up here. So this would have to be 70. We could have also done this. Isn't this 70 on the blue as well? So we could have done that letter Z. There's a few ways we could have got there. I'm going to go ahead and leave that in there. So we could have done the letter Z there, but that's going to be 70, which means that this is 70, 110, 110. Make sure you fill out your vertical and linear pairs and all that good stuff. What else can we know? It might be a little tricky, but if this corner is 120, plus 10 is 130, so wouldn't this part have to be 50? Also, this might be a little hard, but that actually touches purple as well. Touches blue as well. If you follow that up to the blue line, we know that this corner is going to be 120. Those are corresponding angles. So that's going to be 60. And if there's another triangle up here, 60 plus 70 is 130. So this is going to be 50. We know this is 60 and 120. All right, this corner is 60. Those spots were corresponding as well. So we got a lot of stuff filled out. I don't even know what the question is. Notice I didn't even look at the question. I'm just filling out everything I can. Well, they want angle CKD. Angle CKD we got. That's this guy right here, 40 degrees. Angle BLC. Angle BLC, that's this guy up here. That's 10 degrees. And then angle A, the angle at the top here, that's 50 degrees. So we were able to get all of that. Nice. Yep. Moving along. Given A is parallel to C, let's see what we got here. A is parallel to C. List every angle congruent to angle 11. Well, here's angle 11, so 9 is going to be the same for sure. Using our parallel lines, right, if I trace angle 11, it's on a purple line. Follow it. Here's the other purple line. So we know that like 11 and 4 are going to be corresponding. And then 4 and 2 as well are going to be vertical, or like 11 and 2 are alternate exterior. Either way, but it's going to be angle 2. List every angle supplemental to 11. Well, that's going to be all these other ones. 11 and 10 are both linear pairs. 12 and 10. So those are going to be supplemental. And then same situation up here. 3 and 1 are going to be the other ones that are supplemental. List every angle congruent to angle 7. Well, angle 7 is not on a parallel line, so the only answer is going to be 5. They didn't say anything about B and C being parallel or anything like that. So we know that vertical angles are going to be equal, but that's all we got there. All right, and that's the end of the show. Hopefully that was helpful. Good luck, guys.